So let's do more of these. You really need a lot of practice. There's a large variety to these problems, and some of them can be challenging. So I'm probably going to mispronounce this, but let's go with Yochanan walked from home to the bus stop at an average speed of 5 kilometers an hour. He immediately got on a school bus and traveled at an average speed of 60 kilometers an hour. So now he's on the bus until he got to school. The total distance from his home to school is 35 kilometers, and the entire trip took 1.5 hours. So we have the total time and the total distance. We have the speed that he walked and the speed on the bus. And so we want to know how many kilometers did Yochanan cover by walking and how many kilometers did he cover by traveling on the bus. So notice the questions again. Yochanan walked blank kilometers and traveled blank kilometers on the bus. So we can use W and B. So this is the kilometers that he walked, whereas B, that's the kilometers that we can say, rode the bus. So we know our variables. Now we need to go back to our information and see if we can come up with some equations here. And it might also help to write stuff down. For instance, for walking, we know that the speed is 5 kilometers an hour, but on the bus, that speed would be 60 kilometers an hour. And we know the total time, and that's going to be 1.5 hours. And we know the total distance. Now, this is just general advice. If you're ever not sure what to do, starting by organizing your information like this is probably the best way to go. Since if you don't know what to do, at least write down what you do know, and then maybe ask yourself, what can you do from here? Well, we know that his total distance is 35 kilometers. And we know that W is the kilometers he walked and B is the kilometers he rode the bus. We don't know what these are, but we know that when we combine his walking and his riding the bus, that he goes this total distance. So let's use that information. This total distance of 35, this is just equal to the distance he walked plus the distance he rode on the bus. So we have one equation now. And we just got to figure out the other one, and we'll probably use this total time. Now, for that one, it's going to be tricky, since we're also going to need to incorporate this speed here. And when you have time, distance, and speed, one of the key formulas you need to know is that the speed is equal to the total distance traveled divided by the time it took. And you could think like driving in your car. If you're going 50 miles per hour down a highway, it's 50 miles divided by 1 hour. It's distance divided by time. And of course, that could be kilometers as well. It could be 100 kilometers in 1 hour, but it's always distance divided by time. Now for us, we know the total time. So let's solve this for time. So time is just distance divided by speed. And if you're not sure how I did that, I essentially multiplied both sides by time and then divided each side by speed. So that you get this time is distance divided by speed. And let's write that out with what we know. So we know our total time is 1.5. And that's going to be combined by time on the bus and time walking. So let's write that in. Time, we can say walking plus time on the bus. Now, the time walking, remember time is just the distance over the speed. And so the distance walking, remember we called that W. And we're dividing it by the speed of walking, which in this case is 5. And then we're going to add the time on the bus. Well, that's the distance on the bus, which we define that. We called that B. That's the thing we need to find, divided by the speed on the bus, which is 60. So this is equal to 1.5. So we have our second equation. And like I mentioned, this one is challenging because you need to know this idea, this formula relating distance, speed, and time, and then you want to be comfortable manipulating it for the variable that you need, which in this case, you know the total time of 1.5 hours, so you can rearrange it for time, which is equal to the time walking plus the time on the bus. And it might look funny, but in reality, it should make sense. If they walk, let's say 10 kilometers, and you divide it by 5 kilometers an hour, that means it took 2 hours. Now, granted, that's not what we'll have here, but that's the general idea. You want to make sense of these equations. So we have our two equations. Now we just need to solve them. So let me make just a bit more room. And for this one, I'm going to solve it for W. So subtract B, you get 35 minus B. And let's plug that in to the other equation anywhere we see a W. So we have 1.5 is 35 minus B over 5 plus B over 60. Now, personally, I find equations to be easier when we don't have fractions. So if we multiply everything by 60, that would eliminate both fractions because 5 divides evenly into 60. So let's just do that. Multiply everything by 60. And we're going to have to distribute it here. So this is just 90. And for this one, you have 60 divided by 5, which is 12. So 12 times 35 minus B. And over here, you would just get B since these would cancel out. Now we need to solve this equation. So let me work up here. So we need to distribute. So 90, the 12 goes into both of these. So 10 times 35 would be 350. 2 times 35 is 70. So 350 plus 70 would be 420. And then minus 12 times B, or 12B, and plus B. So let's simplify. We get 90 is 420 minus 11B. Now I'll move the B's to the other side. So we will add 11B on each side. But we will also subtract 90 on each side. So we'll do that on both, but we'll also add 11B to each side just so that we can make the B terms positive. And 420 minus 90 would be 330. Now dividing everything by 11, we get that B would be 30. And remember, B is the distance on the bus, so that's in kilometers. And we know the total distance with walking and on the bus, if we scroll over, that was 35 kilometers. And we're saying that B is 30, so that means that W, the distance walking, would be 5 kilometers an hour. Now again, you want to make sense of this. If his walking speed, so actually let me first put the answers in. So he walked 5 kilometers and rode on the bus for 30. So if his walking was for 5 kilometers and he's going 5 kilometers in an hour, he spent 1 hour walking. But he also spent 30 kilometers on the bus, and going at 60 kilometers an hour, that would take half an hour. So he did 1 hour walking and a half hour on the bus, which again, that's our total, and our numbers make sense. So 5 kilometers walking and 30 kilometers on the bus are the final answers for this one.